Hello everyone, this is Samuel here. Today let's take a calm walk through a powerful AWS service called Workload Discovery on AWS. As someone who's been in IT for 20 years in cloud and infra management, right, I can tell you this. If you cannot see it, right, you cannot manage it. And that's exactly why this tool matters. So let's get started. As always, we will have a 7 layer of review around this architecture. I'll show the architecture diagram in some time. So first, we're going to start with solution overview, and then we're going to look at the features and benefits of this architecture or the application in this case, and its use cases where all it can be applied. We're going to look at it. And then we're going to have an 1,000 feet overview of the architecture. And then next to that, we are going to look at them in detail, like a layered review of the architecture. And like I said, this is an application, all right? Application or an infrastructure that we can launch in our AWS account, be it production or dev environment or QA environment. We can launch them and it will assess the environment for us. So we're going to look at the deployment procedure overview, how to launch it in any account. Yeah. And then finally, we will have a look at AWS well architecture, AWS well architected design considerations. We'll look at that as the last thing. So let's get started. Let's begin with solution overview. So let me open this picture. So the workload discovery tool on AWS, right? It's a tool that helps us to visualize your cloud workloads automatically, similar to something what we're looking at. And using this, we can collect real-time data about the resources and show them as clear architect diagrams, something like we are looking at in this picture. And what that means is that we don't have to build diagrams manually anymore. How many of you think this is good news for you? We don't have to build the diagrams manually anymore because it's automatic and it's updated every 15 minutes, right? So it's dynamic. And in the world of cloud, right, where things change very quickly, this visibility is extremely important. I can't insist on that any further. So what we just looked at is a sample architecture diagram. It generated by the workload discovery on AWS. And the workload discovery on AWS, that tool, it automatically generates this diagram that we just looked at for all the AWS cloud workloads, or it includes all the AWS cloud services that we have launched in our account. Yeah. And it also maintains an inventory of AWS resources across accounts and regions. So at any given point of time, if I want to look at, what all the resources I have in a particular region, from this architecture diagram, I can, or from this through this application and through this UI portal, I can do a filter, and that will give me a list of all the different services that I'm using in a particular or in a given region. As next thing, we'll talk about the features and benefits of this architecture. So here is what this offers. This tool, when it gets launched, right, it can give us the architecture diagrams, all that built from a live data. So anytime there's a change in the architecture behind the scenes, the diagram also gets changed by itself. And it can also give us an centralized resource view across all our AWS accounts and regions. I said all our AWS accounts. So if we have multiple accounts, we can integrate those multiple accounts to this particular application, and it will scan that account as well. And like I just mentioned, it can integrate with AWS organizations, meaning adding our own other accounts to this architecture or to this application. And it can give us cost allocations, right? It tags our resources with cost information so we can plan them better. So when we look at the resources in the diagram, right, it will also show based on the size, based on the capacity that we have allocated, right? It will calculate the cost by itself, and it will show the cost popping up or cost on top of it, saying this is how much it's costing you every month. DynamoDB, this is the cost, and EC2 instance, this is the cost that we are spending each month for these resources. And it also gives us export capability, meaning when we export our diagrams, right, it gets exported easily in a shareable format. There are multiple formats. It gets downloaded in all those easy to share diagram formats, and we can share them via email or through chat, or you can actually drag drop in diagrams.net. So, you can edit them on and on that way. This export capability is of so therefore this export functionality give us a flexibility to kind of easily share the architecture diagram with others. Talking about architecture diagram, right, it's a great feature. There's a saying, a picture is worth 1,000 configurations, right? So this workload discovery tool, it gives you that picture that's worth 1,000 configurations. Let's talk about the different use cases. Let's try to answer this question. When should you use this workload discovery tool? We should use the workload discovery tool for design reviews to check if our architecture is strong and compliant. We should be using it for security reviews, spotting risk areas quickly, and we should be using it for exploration and documentation. So when you join a new project and you need to understand what's already built in there, right? You should be using it in that scenario. And for cost visualization, like we mentioned, anytime if you want to look at how much are we spending in AWS every month, every year, or every 6 months, right? This is a great tool. This kind of helps us to see every resource with the cost attached to it, and also to find which resource are costing the most so we can take appropriate actions towards it. So in short, whenever you need clarity, this workload discovery tool comes handy. Now let's get to the crux of this video. What I'm sharing is the actual architecture, the full-blown architecture of the application with multiple components. And those multiple components combined together is what makes this a great tool or architecture. As you can see, there's a component called Web UI component. Well, the Web UI component is built with React, and it's a static web page hosted on Amazon S3, and it gets delivered to the user safely through Amazon CloudFront. It allows users to interact with the solution. So there's a static website you see right here, and there's a CloudFront right before it, and users access this static website via the CloudFront. And this is the actual UI through which we interact with the rest of the components, or through which we interact with to get the architecture diagram, or the cost details, or to integrate multiple accounts to this app, right? This is how and this is where we do it. And it uses AWS AppSync and AWS Lambda to handle user requests and configuration changes. And here is our AppSync, and here is our Lambda function within the UI component. So all the user preferences and all the saved diagrams, they're all stored in S3, and they are managed through AWS Amplify. Then comes the data component. As you can see, the data component is present inside a VPC, inside an private subnet. So the data component is where the relationship between those resources, or the information about resource and relationship between them, are stored in Amazon Neptune, a graph database, and indexes, and that data is indexed into Amazon Open Search Service for search and analytics. So it serves as an backend data source that the UI queries with AWS AppSync. And this component acts as a central repository for discovered AWS resources, especially its metadata. And then comes the image deployment component, the one right here. So the image deployment component, it builds the container image using the discovery component. We'll talk about discovery component later or as next thing. Let's first understand the image deployment component. Yeah. So it uses AWS code build, a tool that is used to build or compile a code. So it uses AWS code build and it compiles the code stored in the S3 bucket right here and uploads an container image to ECR right here. So it creates a container image and uploads them to ECR. And the discovery component right here, this is the discovery component. It pulls the image to run resources and the discovery tasks. All right. So this is a pre-stage for the discovery component. Now let's talk about the discovery component itself. The discovery component is used to auto update the changes. This is the component that gives this application that dynamic feel and the dynamic flavor. So the discovery component runs as a scheduled AWS WAF task, and it's orchestrated by Amazon ECS. And this component, right, it queries AWS config and AWS APIs every 15 minutes to gather resource data and relationships. It compares new data. Anytime there's a new data that comes in, right, it compares that new data with what's stored in the Neptune already, and it updates the graph database and indexes data in OpenSearch. So this is the one that feeds the data component. So discovery component is the one that feeds the data component. And it does all that. It does all its communication and updates the changes back to the data component using AWS AppSync. So AppSync is the one that kind of brokers this action. And then there is cost component here, or a part of this architecture that's responsible for cost, right? And this optional component, it's optional. This optional component processes AWS cost and usage reports. Cost and usage reports. CUR stands for cost and usage reports, stored in the S3 bucket. And it uses Amazon Athena right here, Athena to query cost data. And the results are stored in another bucket and they are paginated to. So the results are stored in another bucket, another S3 bucket, and they are paginated to the web UI using Amazon AppSync and Lambda. So this is the component that's responsible for showing the cost in that architecture, showing that cost, the appropriate cost in that UI. All right, so this is how they all get connected. The web UI component right here, it interacts with the data and cost component through AWS AppSync and the Lambda functions to display resource and the cost information. Now the discovery component, it regularly updates the data component by running all the containerized tasks and the image component for the deployment component right here, right? It's built by the image deployment component. All right. And the storage management component right here, it supports the web UI by saving all the user data and the diagrams very securely. So together, these components connected together provide a seamless, up-to-date visualization and cost analysis for our AWS workloads. Now let's talk about the different layers in this architecture. We'll start by talking web UI and storage management. So as you now know, the workload discovery on AWS has an web user interface that helps to see and manage our AWS resources visibly, right? And this UI is built using a tool called React. You know that now. And because it's built on React, it's fast and easy to use. And to keep the UI safe from all the different attacks that's out there, attacks like cross-site scripting, which can be harmful, we are using Amazon CloudFront here. And this CloudFront adds an extra security layer to every web request that comes in, making sure the website is protected. And the files and code of this UI application is stored in an S3 bucket called the Web UI bucket right here, which is an Amazon S3 bucket. And the CloudFront in front of it, it distributes these files to users around the world if you want, so they can work quickly and securely. Now, this makes everything work. To make everything work smoothly, this solution uses AWS Amplify. Now, AWS Amplify is like an helper that connects the web UI with other AWS services, especially with AWS AppSync and Amazon S3, so the web UI can talk to the backend easily. AWS AppSync is important because it lets the web UI ask for information and send commands like adding new AWS accounts or regions to the monitor. So, in short, the web UI is built with React and served securely via CloudFront. And the UI files here are stored in S3 bucket called the Web UI bucket. And it's the Amplify which helps the UI connect with the backend service. And AWS AppSync and a Lambda function here, they work together to manage configurations like adding new accounts or regions. Simple, is it? Let's now talk about the data component. Now, this data component is like a brain that gathers and organizes all the information. And here is how it works in easy steps. So when you use the web app, right, that's the user interface, it sends a request to a service called AWS AppSync. And this service, it acts like a middleman between the app and the data. And then AppSync calls special small programs called Lambda functions, specifically the Gremlin resolver or search resolver. And these functions know how to ask the right questions to the database. For example, imagine you're fetching all friends of a user. For example, all friends of a user from a social network stored in a graph database. You would be using Gremlin resolver using Gremlin query to do that. And let's say, suppose talking about search resolver function. Suppose your app needs to search for all books that have AWS in the title. The search resolver would handle that and bring back the list from the open search. And here the databases are Amazon Neptune, which actually stores information about how your AWS resources relate to each other, like a graph, and Amazon Open Search Service, which actually helps search through the data quickly. We just learned that through an example. And these Lambda functions, right, they get the answers from these databases and send the information back to the web app so you can see all the updated diagrams and the details associated with it. On the other side of it, right, the discovery component, another part of the system, it collects all the fresh data from your AWS account every 15 minutes and it sends this new information back to the data component through the same API used for AppSync. So the databases there, they stay current. In short, right, the data component is the part that stores and serves all the information about your AWS resources and their components, making sure the visual diagrams you see are accurate and up to date. Now let's talk about the image deployment component. As you see, the discovery component, right, it runs inside a container. Now think of it like a small self-contained app that can run anywhere. And before it can run, right, AWS needs to build uh, this container image, which is like packaging the app with everything it needs. And this is where the image deployment component comes in. Its job is to build that container image for the discovery component. And this is how it works in simple steps. The code storage. The code for the discovery component is stored in an S3 bucket called the discovery bucket. And the code is then built using AWS code build. So when you deploy the workload discovery, an AWS service called AWS code build downloads this code from the S3 bucket, and then a container gets created. So the code build uses the code to build the container image, packaging the discovery component, packaging the discovery component app so it can run as a container. And then the image is stored after building, right? The code build uploads the built container image to Amazon Elastic Container Registry ECR, which is like a library where the container images are kept and are ready for use. So after this is all done, right, at a later part, the discovery component spins up a container using this container image on AWS Fargate service. We'll look at it in the next slide. So that app will now collect the data about your AWS resources every 15 minutes. So in short, the image deployment component is the part that prepares and packages the discovery app into a container image, making it ready to run and gather information about your AWS workloads. Now let's talk about the discovery component. Well, the discovery component is the main data component or the main data gathering element of this architecture, and it's responsible for, as you can see, it's responsible for querying AWS config and making the describe API calls that helps it to maintain the inventory of resources and the relationships between those resources. And this component, right, it launches the containers holding that app. And and as I've mentioned earlier, the Fargate tasks or the containers here, right, they are scheduled, or the app is scheduled to poll every 15 minutes. So the Fargate tasks here are scheduled to run every 15 minutes. So they wake up, come online, do the task, and then they go to sleep or they get terminated. And then another task wakes up, does the job, goes to sleep, and then gets terminated. So we save cost there. So when the task is running, it collects the resource relationship data and it inserts them into Amazon Neptune Graph database and Amazon OpenSearch service. The the discovery component here, right? This workload consists of the following things. The main component is Amazon ECS. It invokes an AWS Fargate task at a 15-minute interval that does the scanning and report generation. So the Fargate task here gathers resources data from AWS config, AWS API describe calls, and from the Amazon Neptune database. Now let's talk about the cost component. So this architecture uses something called as AWS cost and usage report, or CUR for short. And think of CUR as an detailed bill for AWS. So to get this cost info, we first need to set up CUR in AWS. That's a service. This report is then saved in Amazon S3 bucket. The workload discovery tool, the one we saw before, that tool, it then asks AWS for the cost information. And it uses Amazon Athena, as you see, to ask questions about the CUR data. So this cost component helps us view and analyze our AWS cost within the workload discovery tool. And using that, we can see how much each resource or service is really costing us. And to enable this cost feature, we need to create an AWS CUR, and we'll have to configure it to deliver reports to the cost and usage report bucket. We might have questions like, what about that bucket? Well, due to the size of AWS CUR, the responses from Amazon Athena can be very large. So the solution stores the results in Amazon result bucket, Amazon S3 bucket, and then it paginates the results back to the UI. That's what happens here. Next, let's talk about deployment overview. Well, deploying this wonderful app is all automated using AWS CloudFormation template. There is an AWS CloudFormation template available. If we do a search within the account, we'll be able to get that template. And there are some prerequisites. That's First, we'll have to verify that we have AWS config set up properly, and then make sure that we have a proper VPC configured as per the guidelines. It's all there available. I mean, the documentation is available when we launch this application. And this whole application deployment takes approximately 30 minutes. So let me fast forward, walk you through on how this workload really gets workload discovery on AWS really gets launched in an account. So we first need an AWS account with proper permissions, and then we deploy the workload solution using the CloudFormation template. And the CloudFormation template, right, it automatically creates all the AWS resources in our account. The S3 we saw, the Lambda we saw, the AppSync, the ECS, and all that, right? So that creates all the resources for us. And then when the deployment gets started, right, the front end deployment, the user interface part, right? The Amazon S3. Let me open up this architecture here. So talking about the front end deployment, the user interface part, the Amazon S3, the web UI bucket, it gets created and it holds the web UI files, the HTML, CSS, JS files, right? They all get stored there. And then there is CloudFront in front of it. It's configured with AWS WAF. That's to protect the web UI bucket, which is also a static web page. And then there is Cognito there. Cognito is configured for secure user authentication. And then there are some backend API setups. Now connecting UI to the backend, right? And it requires AWS AppSync. It's deployed to create an GraphQL API. An AppSync connects to different AWS Lambda functions. The setting function, which saves the UI settings, the Gremlin resolver, it talks to Neptune for relationship, and the search resolver, it talks to OpenSearch for resource search, and then cost function like fetching, billing, cost info, all that using Athena. They all get deployed. And then the cost and usage report setup, the AWS cost and usage report, CUR in short, it is set up automatically using the CloudFormation template, and CUR delivers detailed AWS billing data to the S3 bucket. And Amazon Athena there, it queries the CUR data for all the queries about or questions about cost information. And the query results are stored in another S3 bucket called the Athena results bucket. Right, so all of these gets created, and the logic between them are connected through the CloudFormation template. Now the real scanning and resource discovery part starts. So the Amazon S3, the discovery bucket, it stores the discovery source code right there, right here. And AWS code build builds this code into a Docker container image, right? And then it stores it right here. And Amazon ECS Fargate runs this container on a schedule every 15 minutes. And this discovery service scans your Amazon account. What it does is it talks to AWS config for resource history and changes, and then it uses AWS SDK to gather all the live. It uses AWS SDK to gather all the live resource data, right? And then we have data storage and search setup. In that part, we have Amazon Neptune, which stores the resource relationship between the graphs. For example, this EC2 instance connects to this RDS. That information is available there. And then the OpenSearch service, it stores all the searchable resource data is there. And then we have the user access experience, right? So once this is all done, the user opens the CloudFront URL. After the deployment is all complete, the user opens the CloudFront URL. The user is authenticated using Cognito, and the user can view their AWS environment using browse resource. They can search for details. They can see how resources are connected and so on. And they can also see the cost information right there in front of them, right? So this is how it's all connected. And once deployed, this is how it functions. And this deployment could take somewhere between 20 to 30 minutes for it to auto deploy and launch and give us that CloudFront URL. 30 minutes. Now let's talk about AWS well architected design considerations. This application is well built on this well architected framework, and the things we can learn from it is it's designed for operational excellence, meaning everything is automated using infrastructure as a code. It's designed for security, meaning we have Cognito, which authenticates users and keeps the access protected. It's designed for reliability, meaning we have serverless components here. They ensure high availability for us. We have performance efficiency is inbuilt here, meaning the managed services here, they reduce the overhead. And this architecture is well designed for cost optimization, meaning we only pay for the services we consume. And this architecture or this application is sustainable, meaning the serverless and managed services here, they reduce resource wastage. So if you're designing an architecture like this or any AWS architecture, right, it is our responsibility to always think long term. Good architecture is not just about today, it's about how what we build survives tomorrow, right? So let's summarize. Based on the past experience, right, I can say one thing, and it has always been true. You can't improve what you cannot see. And this workload discovery gives you the full view of your AWS environment. We can view them live, we can view them organized, and this tool is very reliable. And if you're a budding cloud architect, right? If you're a budding cloud architect watching this video, mastering tools like this will make your work life much faster, smarter, and you'll also be more trusted by your team. That's all we have for today. Thank you for learning with me today. Keep building with excellence. See you in the next section.